Thank you, Dr. Murthy, and thanks to global big data community to offer me this opportunity to speak. So really excited for the actual event. Would encourage you all to come to the actual event and check out our talks. So maybe I can start with a brief introduction. So I'm a principal engineer at Verizon. I also manage a lot of analytics specifically for Verizon Cloud. It's a consumer cloud product. And have experience in software programming, and I also have an MBA from Kellogg Northwestern University. So the reason why I was excited about this conference or talk is we are hearing a lot of activity, buzz, and chatter about Metaverse, and so I wanted to use this opportunity to highlight how 5G technology is being implemented and how it can actually have an impact on IoT devices and enables Metaverse. So I can share my perspective on that. So before we begin, just wanted to highlight like what is 5G technology. So you're probably familiar with 4G, 3G, 2G, and like 1G. It started with that. So 5G is just another evolution in mobile network technology. So primarily, it offers a greater speed. So that's the main key component. But apart from that, there are also other benefits like very low latency. Latency is defined by how quick your processing and the response time is, and so you also get like very low latency. And lastly, 5G also enables a lot of devices through a network. So like currently we use 4G technology, so you have a cell phone tower sitting somewhere, but cell phone towers, these current technologies are limited with the number of devices. So 5G actually also enables to increase the number of devices that can be handled through the network. So, but broadly, as I said, these are the key benefits. So 5G is actually expected to create almost or enable $13 trillion of goods and services exchanged globally by year 2025, I believe. So there's a lot of like economic value that is being unlocked. At the same time, there are new applications that are going to come about, and one of it is actually like Metaverse as well. So 5G is unlocking this new economic value, creating a lot of jobs by primarily unlocking new applications or use cases. Now, first thing I wanted to highlight was the number of devices or the IoT devices. So currently in 4G technology, you're primarily relying on like Wi-Fi or 4G technology outside, but it's still limited. Let's say if I'm talking about connected cars example, you want like cars to talk to each other, you want to maybe prevent accidents. Currently, 4G technology won't be able to support that, but with 5G, it is possible. So hence, like one of the important things to keep in mind is the number of new IoT devices. So you'll see like more drones, you will see like VR goggles or AR, augmented reality goggles, or other kind of like wearables, etc. from a consumer point, and also from the enterprise, like host of like IoT devices for like, let's say, manufacturing, supply chain, and so on, will be unlocked through this whole 5G. So first thing to keep in mind is the number of IoT devices is significantly going to exceed or grow in an exponential fashion. So one of the IoT devices, again, I wanted to go deep dive, is the augmented reality or the virtual reality, which is sort of like the front end part of like Web 3.0, which is going to enable this metaverse. And metaverse is again like I don't think of it as like a new concept in some way. There is already like substitutes for it, like through gaming, for example. There are a lot of like VR applications out there, but I think like this terminology has become like more prominent in the recent times, thanks to like Facebook, which is now Meta. So it's become like a buzzword and everyone's doing it. But at the same time, it has been like undergoing a lot of change in the last decade, and so people are already implementing to a certain extent and largely in gaming. So the first thing is with these new IoT devices like VR and AR, and along with 5G, you're actually going to see unlock more use cases. Like I can go on a street, for example, I'm walking, I can more likely not use VR, but like more likely to use AR, but I can actually see like maybe a menu of a restaurant before even I enter just outside. So I think these kind of like new applications like connected cars or augmented reality, or even connected drones. I think all of them actually will contribute to this whole new terminology, which is the metaverse, or like this new virtual world, as you can call it. So one of the things, again, from the front end point of view, you have like these new IoT devices. The second part is like there are a lot of applications that are going to be hosted on these devices. So let's say I have like an AR goggles or a virtual reality headset. You will start seeing like more and more applications. Already Oculus has like close to like 10,000 or more applications, and they're like every day new applications are coming. So on top of these devices, you will start seeing like more applications that the users can start like engaging with and benefit, again, not only from like consumer point of view, but also from an enterprise point of view. So the first is the IoT devices. The next step is the applications. There is also two other components to it, which is the AI or the data that is supporting or enabling this metaverse. So you will have like, with these new set of like interesting cutting edge technologies, more likely that the world will adopt AI technologies, especially you want to like automate a lot of things, you want to provide low latency. So you can't like use like old fashioned processing, but you'll have to like leverage on AI. So data becomes like very critical here. So that these AI models will be actually like supporting these applications that and IoT devices that I earlier spoke about. And the last component, I would say, in this like whole Web 3.0 ecosystem is distributed computing as well. So with 5G, for example, you can't always rely on like cloud computing. And I know like we have actually moved away from like on-prem computing to like now everyone's thinking about cloud computing or already doing it. But like, let's say you want to operate on very low latency, you can't have like connected cars trying to communicate with each other, but the data center is sitting in a different state or a different country, because the latency will not be sufficient. So what you'll have to do is like actually focus on like distributed computing across the network, or even like edge computing, which is something that a lot of companies are trying to pioneer and deploy. So hence, like computing again in this whole metaverse universe will actually not be just cloud computing at one location, but it'll be more distributed. And I think like with blockchain, with edge computing, distributed computing will become like more important and prominent. And hence, like for these AI models to work effectively, they need to actually manage this distributed data, because data is now sitting in different places. So how do you get all of these? How do you provide like computing power or like low latency for managing all this data at different locations? So I just wanted to highlight these main ideas of like what is metaverse, how is 5G and IoT devices going to enable this metaverse, and lastly, the distributed computing is also like a significant key component. So I'll stop here. If there is any questions, I can address that, but otherwise, I'll have a full-blown presentation for the actual event this month. Thank you all.
Thank you for the opportunity to speak today, and for the upcoming conference. Looking forward to giving the full version of this talk. But as mentioned, the topic is AI and XR for investigations. I just want to give sort of an overview of what will be covered in the full talk. So to start off, background on Kineviz. We are a data visualization company, a small startup based in San Francisco, that develop a software called AIXR. And AIXR is a visual analytics tool designed to sort of bridge the gap between the very technical users, data scientists on one end, and the business users, the non-technical folks like myself, who have sort of the domain expertise and who are the ones oftentimes asking the questions of the analysts, the data scientists. And we work also as a consultancy, creating custom solutions based around AIXR. And within the United States, a lot of our work is in the healthcare medical research space. In the EU, we are more involved in law enforcement and counterterrorism, and that is the topic of this research around the AI and XR. So in terms of why there is a need for bringing AI and XR into the law enforcement world, it's really about enhancing the capabilities of the public safety personnel to protect people and to thwart bad actors, be they criminal, terrorist, some combination thereof. And the resources available today to bad actors has really grown thanks to our always online society, the ability of people to either gain personal information about the general populace, or for that matter, to distribute misinformation. And what you see is sort of a blurring of the lines between the physical and digital worlds, where something like the January 6th attack, for instance, is a planned online, but then turned into real world violence. Another topic I'll talk a little bit about is in healthcare, ransomware attacks, DDoS, other cyber attacks that end up causing real loss of life. This is part of, but not all of, the area for the application of AI and XR. It also is more available in traditional sort of physical only crime, but I'll talk about that in more detail. The thing that makes this interesting and at the same time very challenging is that it's the intersection of so many different domains. And in some respects, the technical challenges are actually the easy part, even with the constant evolution in XR hardware, AI, and big data capabilities. Those, at least coming from a technology company, those are sort of easier to navigate than when you get into things like the legal, ethical, regulatory dimensions of working with law enforcement, where you have to be cognizant of things like evidentiary requirements, or how does the jurisdiction work for crimes that are committed both physically and online. The ethical dimensions, especially working with AI, we've seen studies showing that there is reinforcement of unconscious bias around various demographics, race, and gender that can be caused by some AI technology based sort of on the learning materials, as well as even with VR hardware, there's some evidence that suggests that headsets are more likely to cause cyber sickness in women than men due to things like the interpupillary distance. These are just a few examples of the kinds of concerns that need to be factored in when you're developing for a public safety audience, as well as the regulatory side and working the EU. There's, of course, GDPR, the General Data Protection Regulation, which is a huge part of the data gathering and data management consideration. And finally, there's also the commercial dimension of what makes this actually useful to the end users, what makes this so much more beneficial that it's actually worth interrupting their existing workflows and tools to incorporate new technologies. And that's not always the case. That is the poster from Minority Report, and then the other image sort of represent, to my mind, the two pitfalls. On the one end, there's Minority Report as a cautionary tale, the notion that bringing AI and XR into law enforcement can potentially result in sort of an erosion of privacy and of the individual rights, which is certainly a possibility that needs to be guarded against. At the other end of the spectrum, there is sort of the wow factor that got XR on so many folks' radar just a few years ago. This enthusiasm about the potential that is not necessarily backed up by actual usability. And for public safety people, there's really very little interest in potential and wow factor. They want tools that are actually going to help them here and now. And so I'll be talking a little bit as well about what AI means in this context, things like clustering, pattern finding, recommendation, and how those are both applied to the underlying data and in the actual workflows that are being researched. And it's also important to really understand what is that underlying data. It's not going to necessarily be things that easily fit into a spreadsheet when you're pulling information from sources like social media and geospatial imaging and a really wide spectrum of documents and data sources. And the underlying data store needs to be able to support analysis of these different forms of data. And so that is really important to understanding what the role of the AI is. And data visualization is key to making that information accessible both through the AI and the underlying data in a variety of ways. You could, for instance, a sort of simulation or recreation of a crime scene is one very natural way to imagine XR being applied for investigations, being able to see the crime scene as it was discovered, even if you're not able to actually physically visit it. But there are also much more abstract dimensions of the data that can be visualized to help either analyze things that have happened in the past, or also to try and anticipate potential future actions. So high dimensional data visualization, connected data or graph data, and visualizing these in geospatial and temporal contexts are some of the ways that the data is visualized in XR. And the other really important aspect to visualization in XR is just the notion of collaboration. How do you, we're all familiar by now with the Zoom call and that moment where you point at the screen and realize that no one can see what you're pointing at. And in XR, you have the opportunity to interact with things in a much more natural fashion. And in AR, there's also the possibility of having sort of a hybrid working dynamic where there's someone on site working with people remotely and being able to, again, have this sort of shared context. So that's sort of the big overview of where the research around AI and XR stands from our perspective.
So I'm Nicholas Longano, I'm CEO of Scooty. For those not familiar with Scooty, it's a universal rewards and Metacommerce marketplace. And it was created to bring together game makers, players, and brands in a symbiotic relationship. It does encapsulate much of what I'm going to be presenting in terms of rewards and the importance of those to Metacommerce, to games, and to the Metaverse as well. As you saw, as I was loading this, the marketplace is accessed from any game and launches from the lobby without ever interrupting the player's game or Metaverse experience. And that is key, and I can explain all of that. Now, for some, the Metaverse seems like an abstract, far-off idea, but the metaverse is already rapidly developing through virtual worlds. And as Harish mentioned earlier, they've been growing and iterating for over 14 years now. So this is not a new concept. The day these virtual worlds can be interconnected and traversable is the day we officially have the metaverse. And that day is not as far away as it may seem. Now, developers like Atom Universe are already making interconnected and virtual experiences for brands. And that's where solutions like Scooty, which we've built, right, play a very important role. And I'm going to explain that because, our marketplace makes shopping in games and the metaverse a positive experience, right? And it's all done through interoperable wallets. Interoperability is key in the metaverse. And that interoperability or that wallet facilitates purchases, rewards across all games and all experiences. Now, Metacommerce or commerce through the metaverse is literally Web 3.0 of e-commerce. And we believe that the gaming industry is going to fuel that adoption and that growth. Now, the utility of the metaverse is that players can take their gaming identity or their persona, their virtual wallets from one experience to another. And it's really the player that's in the driver's seat with the metaverse. Brands get to build positive rapport and they can fuel the reward system, right? While being able to market and sell directly. This means a better game experience, and I'll explain that, well, what that means and where I'm going with this. It means a better game experience for players, new revenues for the game makers, that's key, and access and ROI for the brands that are fueling all of this. So you may ask yourself, do players actually want the convenience of shopping from their game or from their metaverse experience or virtual world, whichever you want to call it? The answer is an unequivocal yes. In fact, I recall folks asking themselves in 1995, would web surfers ever want to shop from their Internet Explorer? We know the answer to that today. Of course they do. And of course, gamers would want to buy from their games, especially, right, if that purchase is giving them rewards and those rewards are making for a better game experience. We have heard it from gamers time and time again that they would buy physical goods from their games. Think about it. It's logical. They're going to buy a product anyway. Everybody shops. Now, that purchase, if they were to make it through their game, is going to reward them in a way that can actually enhance their game experience. It's a huge win. So the better question that people should be asking is, why would any player not buy from commerce platforms like Scooty through their games? And I don't have the answer to that. Now let's talk about rewards. Rewards programs drive loyalty, retention, and conversion in literally every industry. Sports, retail, travel, even the coffee I drink in the mornings. Who doesn't love rewards? And these rewards are all fueled by commerce. And what I mean by that is you buy something and you get something free in return, a reward. Gaming is literally the only industry that has not integrated this strategy of commerce-fueled rewards. Every time a player shops through platforms like Scooty, they can receive up to 5% back in the form of rewards, and they can redeem these rewards to buy other physical products. They can exchange them for in-game credits, digital items, NFTs. They can use them for peer-to-peer wagering. They can gift them to other players, or they can donate them to their favorite charities. So why would they buy elsewhere? They are the same goods, say that, let's just say, give an example. I buy a pair of New Balance sneakers. Those New Balance sneakers are still being shipped directly from New Balance, but now New Balance is giving the player, me, a reward. And I can use that reward to have a better gaming experience or a better metaverse experience. It's logical. Now, brands, as we all know, have historically had difficulty selling and advertising to gamers. In fact, most of the advertising practices that are out there, with the exception of native in-game advertising, and I mean billboards within the game, most of them are contrarian to what a brand really wants. A brand wants to connect with players. However, today's advertising basically ejects the player from their game. It cuts the immersion. And if I was a game maker, I would never use strategies like that in my game. I want to retain my player. I don't want them to leave my game and go to and launch some website. So things like GCommerce, which is what we're developing, right, lets brands effortlessly reach gamers directly. And what's even better is that GCommerce, or commerce through games, I'm playing with words here though. We created GCommerce, by the way. Commerce through games never interrupts the game immersion. That is absolutely key. I'm a gamer. I do not want my gameplay being broken, and I don't want to be taken from the immersion that I have in my game experience. That goes, whether it's a game or a metaverse experience, it's irrelevant. And it never removes the players from their gameplay experience, right? But instead it rewards them for every action, right? It allows game makers now to tap into a completely brand new revenue stream. And that revenue stream, by the way, is 30 times greater than the entire gaming industry put together. Think about it. Every person shops. It's a $6 trillion plus annual business. The gaming business, as we see it today, pales in comparison. So GCommerce and Metacommerce can optimize every single game maker's revenues exponentially. And that's what's compelling here. That's why we created this to begin with as an industry. Now, consumers, right, can actually live their favorite brands. They can demo new products and they can shop socially through their games and obviously through any metaverse experiences as well. Real world shopping can't compare to this, right? In the metaverse, players will have a digital passport or fingerprint, and which is carrying all the information about their identity, what kind of gamer they are, the games that they're playing, etc. And this is all information that they volunteer. There's no cookies, there's no tracking, there's no privacy invasion. None of that, because players are rewarded, because if they share that information, then they get better products, better offers. It's all curated, and who doesn't want curated products, right? And better than that is that I'm getting rewarded with each interaction as well. Now, brands will not only fuel games and metaverse revenues, but they're also going to provide players with both status and utility in the games that they're playing. Okay, so let me give you the New Balance example again, right? Players buy a pair of New Balance shoes. I'm talking about the real shoes, physical shoes that get shipped to my home. Let's say I paid $100 for those. New Balance gives me $5 back in the form of rewards, or they give me this nice looking avatar, or sorry, not avatar, but digital New Balance shoe, which I can now wear in my game experience or in my metaverse experience. Guess what? That shoe, that virtual shoe, makes me run 10% faster, and I can jump 20% higher. The brand, and in this case, New Balance, is helping my game experience. I was going to buy those shoes anyway. There are other sites where I can go buy them, but I'm going to buy them here. I'm going to buy them through my game. And by the way, the game maker just made a huge percentage off that sale as well, which they can now put in their pocket and use to make a better game experience and continue to iterate that for me. So it's a constantly evolving and self-feeding universe that we're talking about as we sort of head down this direction. Now, as I mentioned, everybody wins in Web 3.0. Players get curated products. They get uninterrupted immersion with their games or their experiences. There's no tracking. There's no privacy infringement. They can spend their rewards as they wish. They're in control, right? Across any game, any experience that they like. I can earn here and I can spend over there. Brands get to connect with them directly and convert a new gaming audience, right? They really haven't ever had this level of access before. And I should mention, this is a mass market audience. When you're talking about 3/4 of US households, 80% of millennials, 80% of Gen Z, and almost 3 billion gamers globally, you could say it's mass market. And it's a big win-win for video game developers. One of the biggest challenges game makers and I had, and we didn't go into my background, I was fortunate enough that coming out of the consumer packaged goods business in the 90s and in the 80s, that's how old I am, I got to work with Blizzard. I got to work with an incredible development team. I got to work with the guys from Valve, Counter-Strike, Half-Life, Warcraft, Diablo. I ran Universal Interactive, right? One of the biggest challenges game makers have today is converting players to make in-app purchases. Only a small percentage of players convert. So now we can let them shop and let them use their rewards to fuel in-app purchases. It's done in every other industry, but the games industry hasn't done it, not until now. So the future of video games in the metaverse will be a closer tie and coexistence with brands. I've been saying this for a couple of years now. And just as brands fuel the sports I watch, the TV I enjoy, the concerts and music I listen to, so too will they fuel the game and metaverse economy, always putting the player first and always preserving the gameplay integrity. And we'll get really deep into this in a couple of weeks.
Yeah, let's talk about the, I'm going to just give you a real brief introduction into what I plan to talk about. A lot of the information is one way or another on my blog. I do a lot of things where I look at and try to seriously evaluate technology. I'm probably the resident curmudgeon or the resident skeptic on a lot of things going on in AR. I try to keep people real in the world of augmented reality. Let's see. Okay, there we go. So I thought I'd give you just one overview slide of this is kind of like the entire presentation. We talk about some of the key issues, there's a very wide gap between what people sometimes expect versus the reality of what they see. Try to give you a feel for why it's so difficult. Why are people spending billions of dollars? For example, Meta spent billions of dollars, and the best they've been able to do is like the Facebook Ray-Ban glasses, and they don't have any AR in them. They just have audio. There's no video. Well, it's a hard problem in spite of the billions of dollars they're spending. We'll talk about locking images to the real world a little bit, probably a good bit more about human factors and some of the issues like power and heat. I'm oftentimes fond of saying that amateurs worry about battery life. Professionals in this area worry about heat. It's the heat management and getting rid of heat that's actually a bigger problem than the power itself. So we're going to talk about various types of optics from bird bath. That's what you see with the N-Rail, and there must be a dozen companies doing that kind of thing today. We'll talk about diffractive waveguides. There's a dozen companies working in diffractive, most famously HoloLens, Magic Leap. Snap bought a company called Wave Optics, DispelX. We'll talk about reflective waveguides, which right now have much better image quality and are much brighter. We'll talk a little bit about some of the off-axis large combiner stuff. Campfire, which used to be, basically bought the technology of the old Meta, the original Meta, before Facebook bought the name. And then Mira and some guys like that. We'll talk about dimming inclusion. I've got some stuff about the Magic Leap 2. We'll talk just very briefly about pass-through AR, which is where you take VR plus a camera. And a lot of people think that's a panacea, but it's not. It just trades one set of problems for even a bigger set of problems. But there's a lot of talk that Meta is going to be going that way, maybe Apple as well. And there's a small startup called Lynx is working with that. And we'll also briefly mention pancake optics, which is a little far afield because it's really for pass-through AR. But there's a lot of talk, Meta, Apple, and some others may be looking at using pancake optics. So I thought I'd touch on that real briefly. We're going to talk about various display devices. Right now, the king in many ways is LCOS, liquid crystalline silicon. DLP seems to be receding. We'll be talking about micro OLEDs, which are used widely in these bird bath optics, some about micro LEDs, and we'll talk some about laser scanning, which I am fairly well known for being, for basically saying it's most of the laser scanning I've seen has been very poor. And along the way, we'll mention quite a few companies because I like to talk in terms of reality of what's being done. So as I oftentimes say, people start with a view of Ray-Ban sunglasses and end up with HoloLens, basically a cut open helmet. And I'll start to talk about why that is. Also in terms of image quality, like HoloLens and many others will show you their video feed or their idealistic feed, or even worse yet, some computer rendering. but this is what it ends up really looking like. So this is why I talked, there's a gap between concept and reality. And we'll get into, I'm just going to very quickly flip through a few slides here, mostly visual ones, to show you kind of what I talk about. But we'll talk about why AR is so difficult. Issues such as transparency. You know, some technologies, you can see the eyes. This is a much more friendly environment than when, say, you can't see somebody's eyes. Many of the technologies go a long way to blocking the eyes. So you know, that's an important factor. It also means that you're dimming the real world. This is kind of a two-way street. When you look out, if you're blocking, many of these technologies block over 70% of the light. So it's like wearing dark sunglasses. We'll talk about other human factors, such as what I call front projection, also known as glowing eyes. We'll get into a little bit on things like what are birdbath optics, how do they work? By the way, there's no math involved in all this. It's all kind of, I'm trying to give you a high level view, but try to give you some level of understanding of what's behind the technology. So this birdbath, which is exemplified by Nreal, but there are a dozen companies, Lenovo and others, doing stuff very similar. We'll talk a little bit about pupil expanding waveguides and some of the issues there. Loomis is a non-diffractive waveguide technology that has demonstrated some superiority in terms of image quality and efficiency. We'll hit on Magic Leap 2, what's going on there, and particularly dealing with their dimmer or their area dimming architecture and what are the issues with that. We're going to hit on various display devices, as I said, from micro LEDs to laser scanning to LCOS. Here's an example I picked from my website showing the difference. HoloLens 2 went from HoloLens 1 with LCOS to, I think they went backwards with laser scanning, at least in terms of image quality. We'll talk some about micro LEDs and LCOS, and one of the trends going on today is people are going small with their optics. Avegant and Digilens are both got very small, much smaller engines. They're saying, hey, if you want to do small stuff like below 30-degree field of view, and one of the other topics we need to talk about is the bifurcation. I'm seeing there are companies trying to do 40 and 50-degree field of view and above, and there are people trying to do smaller than 30-degree field of view. And we'll get into some of why do you do that. Here's an example comparing a Digilens LCOS versus Vuzix using a JBD, Jaybird display micro LED. These are actual pictures I took through the optics. We'll talk some about the human factor issues. This is an example of HoloLens 2 versus Magic Leap 1 and what are the issues and what made HoloLens 2 so to me so much more interesting. Let's see. We've got talk a little bit, show you like here's a Loomis Maximus. They've got some really neat stuff that has demonstrated much higher resolution and better image quality, much better color uniformity and so forth. Then here's a recent thing on laser scanning. I took these at I think AWE this year. So it shows you some of the issues with laser scanning. Like I say, every time I've gone to shows to look at laser scanning demonstrations, I went in with low expectations and they seem to always get under them. And then in the end, I'm going to wrap up with a little bit about how some technologies work better with other things. So on the left here, we have basically display technologies. And on the right, we have various optical technologies. And so you kind of mix and match and try to figure out not all display technologies work very well with all optics technologies and vice versa. So we'll kind of wrap up with that. So that's about it.